What is 64-bit computing? 64-bit. A 64-bit computing architecture is one that contains GPR or general purpose register that can hold 64-bit of data. 64-bit of data. Similarly, a 64-bit instruction is one that can operate on 64-bit operands. 64-bit computing, as you said, this is 64-bit. Now this is 32-bit. 64-bit means now you can just double the size of the registers also and the instruction also, right? This is the code stream. This is the data stream. This is 64-bit data, and these are 64-bit registers, and of course these are the mixture of 32 and 64-bit data. So the data which can be handled by 64-bit is 32-bit also, means back compatible. 32-bit and 64-bit both can be handled. In the programming models, this is your 32-bit, this is your 64-bit, and by the size of these two figures, you can estimate that the size are double. Of course, the PC program counter is also taking the doubles PC size. These are the double register size. And what do we mean when we say 64-bit computing? In 64-bit processors, our data stream doubles in size from 32 to 64, and hence the GPRs, general purpose register, these are doubled in capacity. The instruction stream remains the same size, and therefore the IR remains fixed, instruction register. In terms of data stream, the modern processors, the data stream is composed of first the integer and address data, which are operated on in the ALU, arithmetic logic unit, with associated registers, and floating point data, which are operated on in the FPU with associated registers, and vector, that is SIMD, single instruction multiple data. This vector data which are operated on in the vector unit with associated registers. So integer and address data, ALU, function point data, FPU, and vector data in vector unit. The 64-bit architecture, the only difference in moving to 64-bit is in the integer and address hardware. In integer and address hardware, so the data type, which is integer, as you said, address, the data type is if it is integer or address, the register type if it is GPR, the execution unit it can be ALU or AGU. In the x86, that is 32-bit, it was 32, and here for x86 64, these are 64-bit. In this floating point x86, it was already 64 FPU, execution unit when it was FPU. In this, it remained the same 64, and vector also it remained the same 128, 128. So actually the change of the values or the increase in width is in the integer and address hardware. This is Intel ISA. So what do we mean 64-bit integer data? Wider data register increases the dynamic range of integer representation. For example, a 32-bit processor can manipulate how many integers? 2 to the power 32, this many integers. But now a 64-bit processor can manipulate 2 to the power 64 and see the order. By doubling the bits, we have increased the dynamic range by a factor of 4.3 billion. 4.3 billion. And when we talk about the address data, we have just seen the integer data, now the address data. So wider data register also increases the dynamic range of the addressable number. Again the same. Previously, a 32-bit processor was able to address 4 GB of memory. Now 2 to the power 64 is able, the processor can manipulate how many addresses? 180 petabytes. I can assure you this much is quite comfortable for anybody. Now increased memory addressing. See, these are the differences in scale between the architectures. Bits, 4-bit, and the number of memory addresses, you can just take the power of 2. 2 to the power 4 is 16, and likewise all these. So for 4 bits, these are the number of memory addresses equivalent in bytes, and these are the scales. For example, if you use 16 bits, you can address the population of a small city. With 32, we can report population of the world. By 64, this many number of memory addresses equivalents in byte. Estimated number of grains in a cubic mile of a sand. This is huge. So what can you do with over 4 GB of memory? First of all, that application that use very large object, that is more than 2 GB object, like video editing, simulation, visualization. An application that use files that are larger than 2 to the power 32 bytes, and this you can memory map very large files like backend servers and databases. What can you do with over 4 GB of memory? Third is large scientific application, which work with numbers outside the dynamic range of 32-bit integers. This causes the overflows and the underflows, and hence sometimes wrong answers are in the output register. So you can check the PSW to determine if such a situation has occurred. In the cryptography, modern cryptography algorithms rely on the factoring and multiplication of very large numbers. The larger the number, the more secure the encryption. But the drawbacks, the disadvantages. Memory address values, we call them pointers, are now twice as large and take up twice the space. The pointers normally take up fraction of the space in the cache. Now they are doubled in size and can squeeze out other useful data from the cache and may reduce the performance. A slight improvement is to tag 64-bit integers during programming. For example, rex, mnemonic, prefix. It increases size around 10% of the current application. The 64-bit code can be compiled on 32-bit architectures. 64-bit data can be processed as 2 32-bit calculations, although performance penalty is incurred. Only applications designed to process 64-bit data are implemented on 64-bit hardware will achieve any. So this was about 64-bit computing. Thank you so much.